Welcome, class. Today our session title is Week 9, Session 33, Mole Ratios from Balanced Equations. We will move slowly and make the chemistry understandable. Your goal is to use coefficients as mole ratios in chemical reactions. Listen for these key terms: stoichiometry, mole ratio, coefficient, balanced equation, conversion. First, keep the three chemistry levels together. Stoichiometry uses a balanced equation as a recipe. Coefficients tell the mole ratio of reactants and products. They do not directly tell grams unless you convert through molar mass. When you feel stuck, ask, what did I observe? What are the particles doing? And what symbol or calculation represents it? The core model is this. Mole-to-mole conversions follow this path. Known moles gives mole ratio from equation gives wanted moles. Do not rush to an answer. Build the model first, then let the model guide the calculation or explanation. Now let's work an example. Using a mole ratio. For N2 plus 3H2 gives 2 NH3. How many moles of NH3 form from 4.0 mole H2 if N2 is excess? Use the ratio 2 mole NH3 per 3 mole H2. Calculation: 4.0 mole H2 x 2 mole NH3 per 3 mole H2 equals 2.7 mole NH3. Notice how the answer comes from evidence and reasoning. Here is a second example. The same equation says 1 mole N2 reacts with 3 mole H2. If you have 2 mole N2, you need 6 mole H2. Coefficients scale like a recipe, as long as the equation is balanced. Now answer this self-check. In 2H2 plus O2 gives 2H2O, what is the mole ratio H2 to O2? A strong answer should include 2 to 1. Hint: use the coefficients. Before you leave, practice actively. Task 1. Use 2KClO3 gives 2KCl plus 3O2 to find moles O2 from 5.0 mole KClO3. Task 2. Explain why equations must be balanced before stoichiometry. Task 3. Write the mole ratio between NH3 and N2 in N2 plus 3H2 gives 2 NH3. At the end of your study, write one sentence beginning, "The chemistry idea I must remember is." For more practice and exam preparation, visit www.bridgetoexam.com.